Good morning, everyone. And I would like to thanks for invitations to be here to present some of my different topic. This is not related to the really the material. So the in this talk, I will discuss how we can use the tunable material for RF or antenna system. So this topic is very good for the real applications in the 5G, some satellite applications, sensor application, or imaging application. So I will discuss today on overview of the tunable material application in antenna system. So I am Nasimuddin, principal scientist. So the outline of my today's presentation, motivation, why we need the antenna system and how we can use the tunable material for the make the system very efficient and low cost. And generally, we use the tunable material for reconfigurable antenna system, how to make the reconfigurable. And then I will discuss the what type, different type of the reconfigurable antenna, and I will introduce the what kind of the tunable material good for the RF or antenna applications. And I will discuss the advantage, what are the advantages of the tunable material based beam steering systems or frequency variable antenna system. I will discuss some of the structures which can really develop based on the tunable material. And I will discuss also some different type of the array antenna which can be used tunable material for different applications. And I will discuss some leaky wave antenna. And last but not least, I will conclude my presentations. So as you know, the tunable material can make the antenna system low cost and power efficient. Generally, for if you design the phase array antenna or beamforming antenna for 5G application, because you have to change your antenna beam system in different locations to connect everyone or everywhere. So you have to have the reconfigurable antenna which can change the beam in different directions. If you want to image the system or if you want to map the some surface to check the detection crack in the metal or concrete wall, you have to have the beam steering antenna which can cover the wide range. So or you have to have the antenna for localization. If you want to human localization or radar application, you have to have the beam forming antenna. The other important thing for future application, the 5G or 6G, the main is the connectivity, how to connect unconnected, how to connect houses, cities, and countries and vehicles, the connectivity for everyone. So 5G aim is the how to connect everyone, everywhere and anywhere. And the other application of the this beam steering antenna system is the satellite. So if you are if you are in the plane, so you have to have always connect with the satellite. Wherever you fly, you need the you need the Wi-Fi connection data to call your family or meeting or something. So the satellite antenna always should connect with the plane. So you have to have the beamforming antenna. If flying, the connectivity in motion is very, very important. And if you are in the ship or you are in the high-speed train, you need to connectivity to get the information from ground or what is the going on in the world. And if you want to play the game, high 4D game or high data rate, you need high data rate. So you have to go the high wideband frequency band antenna. So how to design the wideband antenna with the beam steering antenna. The other application, the imaging, satellite, radar, now the drone system, how to connect always the drone with the 5G system, cellular system, and some space application, airborne application. And 5G, the how to connect the unconnected. So this is the so for tunable material, we can use in the antenna system to change the dielectric property, which is some variable or some excitation. So you know that these are the array antenna, and if you put some tunable material below the array antenna, so that we can change the dielectric constant of the material. Once you change the dielectric constant, so the guided wavelength change. So based on the guided wavelength, we can tune the beam of the antenna if you connected all antennas. So the main important thing of the phase shifter in the antenna technology. So we can design the phase shifter. Phase shift means you need to change the phase between the two antenna elements. So if you have the different dielectric constant material, or you have the like tunable material, you can tune the material permittivity or dielectric constant. You can create the phase delay. So between the two antennas, if you create the phase delay, so you can change the beam. Another important, you can also use the tunable material for changing the frequency of the antenna without changing anything. So you just tune the biasing voltage of the material. You can change the dielectric constant of the material. I will discuss that on this. So other application, the drone. So if you have the drone communicate with the 5G or cellular, so you have to have the reconfigurable radiation pattern of the antenna. So the patch antenna only the ground. If you want to connect in the side or in all directions, so you have to have the wide coverage. So you have to have the different type of the antenna, and then you can switch the pattern using the material-based switching or other. Another application, energy harvesting. So if you have the antenna which can change the beam in different directions, so you can receive the energy from different direction devices, radiating devices like Wi-Fi, radar, 5G, or there are so many radiating devices are surrounding us. So if you have the beam steering antenna which can steer the beam in all directions, the better to get the energy from all directions and you can get the more power. The other application, if you have the fixed antenna system, so you can change the beam to localize the patient in the hospital or in other places. And now is the 5G, 6G terahertz. So now they call the the reconfigurable intelligent surface. So the in future, the all like building have the some kind of the meta surface, intelligent meta surface, which can change the beam in different directions and can be used different applications for communication, for wireless power transfer, or simultaneously you can transfer the power and the information, and UAV connection or satellite or some mobile base station. So the reconfigurable antenna has four different categories like frequency reconfigurable, radiation pattern, so which can tune the beam in the different direction, and that is the polarization. You can change the antenna polarization like right hand, left hand, or vertical polarized, horizontal polarized. So you can change the polarization using the material. And they're the hybrid. They're the some antenna which have the double like radiation frequency or have the three. So the main issue is the how to connect the human or city unconnected. So you have to have the reconfigurable antenna. So reconfigurable antenna, you can change the frequency, either frequency, beam, polarization without changing anything. You just change the biasing voltage of the material. So you can see the polarization, you can change the right hand circular polarized, left hand circular polarized, or vertical, horizontal polarized. And frequency, if you have the like liquid crystal or vector diode type material, you can change the capacitance of the material or some then if you change the capacitance, then the permittivity or dielectric constant of material change. So based on the changing the material property, you can tune the frequency. If the permittivity change from lower to higher, the frequency, if the permittivity higher, the frequency is lower. If the permittivity is reduced, the frequency change. So you can change the frequency by changing the material property using electrically changing the dielectric constant of the material. And the beam pattern also, we can change the beam direction in different directions based on the creating the delay between the, and they're the hybrid type of the reconfigurable antenna. So the system, different system, they're the one electronic system. So we have the electronic system like pin diode, we can use pin diode, vector diode, some transistor or MEMS switching, phase shifter. So this technology is very, very expensive because phase shifter is very expensive, higher frequency. And some phase shifter not available at the millimeter wave or terahertz. So we have to get a different method to use the reconfigurable antenna system. And pin diode and vector diode can be used for low frequency because these are the very lossy. The other type is the material. So we have the different type of material, liquid crystal, phase change material, which can be change the phase from like dielectric or the insulator to the metal. So we can use as a switch. And there are some ferrite materials and the metal surface. Metal surface can be used for dynamically change the material property or the material property, which can be used for antenna, change the pattern, and so on. And the other type is the photonics. You have the semiconductor device, doped semiconductor device. If you put the laser light, you can change the loading, you can use as a attenuator or phase shifter, you can change all the phase shifter. So this is the photonics based also very important, but this one need to very high power laser light. Another is the structure, so no need anything. You have the mechanically you can change the antenna properties or antenna direction to change the beam. So the main focus is the pattern reconfigurable. How to use the pattern reconfigurable to have the beam in different directions with the fixed antenna without changing anything. So this is very important in the future, like 5G, 6 is coming right. So there are the three type mainly. The mechanical is the very simple. You can just rotate the antenna in different direction. You can change the beam. The other type is the reconfigurable fusing configuration. We call the phase array type of switching network. So phase array type beam forming antenna is very expensive. Another problem for phase shifter, you need to heat sink, and the other is the power consumption is very high. And so the cost and the cost is very high of this type of antenna. Another is the unconventional, so which depend on the material, tunable material or pin diode or some reconfigurable intelligent surface. So these are the very, very low cost, but you need extra effort because this research need some in lot of expertise like material. You have to have the material scientist or circuit scientist and the EM scientist and the antenna scientist. Then you can make this antenna very good. Otherwise, if you have only the one type of expert, you cannot design. So you have to have the material expertise. So you have to characterize the material accurately to design. The tunable material approach can be used for reconfigurable antenna system design and has the significant advantage compared to the pin diode and the vector diode, because pin diode, vector diode can be only the low frequency. So if you go the higher frequency millimeter wave or terahertz, so you cannot find in the market the phase shifter and the amplifier or phase shifter. So you have to design based on the tunable material. So the beam, the pattern of the antenna beam can be changed if you create the delay between the two antennas. So this delay can be used tunable material. So if you change the material property at one of the fading line, you can create the delay like this. You have to change the wavelength. If you change the dielectric constant of the material, you can change the lambda guided wavelength. So the delay can be created. So this is the simple method to create the delay between the two antennas using the tunable material. So the tunable material, one important thing, we can have the variable tunability. So if you have the variable tunability, you can continuously change the beam using the variable control of the voltage, biasing voltage. So in the market, there are the two types of the antenna. One is the conventional beam steering antenna, which use the phase shifter or other method. These are very expensive. Another type is the material based, like the Alcam, K-meta, Astropic, and the meta wave and equivalent. So these are the material based. The Alcam is the liquid crystal based. You know, the liquid crystal permittivity you can change based on the biasing voltage. So they have developed this technology, I think, since 2010. So now I think they have the one product in the market. So this technology is very low cost and low power consumption compared to this technology. So this is a comparison. You can see the phase shifter based or the digital beamforming based antenna, and these are the material based. You can see we have the very low power consumption and low weight, and the complexity varies in low, and the cost is also low. So compared to the conventional phase shifter or the digital beamforming IC based phase array, and the material based is the very low cost, low power, uh, low weight, low power. I think the for phase array antenna, power and the cost is very important for industry. So if you reduce the two parameter, I think this is very good. So that's why the Alken company, I think, developed some liquid crystal based phase array antenna. So the tunable material refers to substance properties can be dynamically altered to control through the applications of the external excitation, such as the electric field, DC biasing, magnetic field, and light, and the heat also. The tunable dielectric material are the key component of the reconfigurable electronically beam sterile antenna, which play the fundamental role in the wireless communication system at the millimeter wave and terahertz applications. So we can change the dynamically tunability of the material. So based on the changing the property dynamically, we can create the delay, or we can change the permittivity of the antenna, which can use as the frequency tunability or the beam tunability. And we can use the external stimuli material response to specific external factors. The flexibility, we have the flexibility. We can use the material either frequency or any, and there's a wide range of the tunable properties of materials. So we can use these properties for antenna designing or component designing. So liquid crystal is the one of the very important material for the millimeter wave and the terahertz applications. But the problem for the liquid crystal, I think, good liquid crystal which have the large tunability, only few company in the world, only I think one of the is the German, the Merck also developing the very good liquid crystal, and they have designed some antenna. And the other is the ferroelectric materials. Ferroelectric materials is the good material for low frequency, because at high frequency is the very lossy. And semiconductor material also can be used for the higher frequency, but is very expensive. So only the liquid crystal is very cheap for the millimeter wave. Another is the ferrite, also very, we can use only the low frequency. And there are the meta materials, so artificially material, we can create some material which can be used for the antenna applications. So they are the advantages. We have the flexibilities. We can have the more flexible. We can use either the frequency reconfigurable or polarization and the beam. And miniaturization and enhanced performance. We can reduce the cost and the power consumption, the energy efficient and cost efficient. The application, we can use the tunable material in antenna technology. I have discussed the applications in the antenna, how we can use the tunable materials for these applications. And there are some application in the optics and the photonics. We can design the lens with variable lens, tunable filter and switch also. And the electronics, we can design the reconfigurable circuit like phase shifter or tunable capacitor, transistor, which can be used for the antenna application also. And sensing application, we can design the tunable sensor. Tunable sensor means the antenna. We can design a tunable sensor which can tune the frequency, different uh, bands. The MEMS device is the tunable material is the very important for the changing the antenna technology field. Very we can use in the future for designing the very low cost, low power consumption antenna systems. So this is the some there are the some class of the materials like the phase change material. We have the uh, vanadism oxide is very good for this material. We can use for because this material change the transition from the metal to insulator. So this property we can use the switch. If you change the like you have the line two line, if you have the VO2 and we change the like two line connected or unconnected, we can use as a switch. So this material is very good for switch because this material have the property to change the uh, phase transition because from metal to insulator. So we can use the this material for as a switch. The other type is the semiconductor type. So if you have the doped semiconductor, you can change the semiconductor permittivity or based on the brick area, or if you apply the heat or you apply the laser, you can change the doping. Another liquid crystal. Liquid crystal is very good if you apply the biasing voltage and using the very fine tune of the biasing voltage, you can control the permittivity of the liquid crystal. And the other type is the graphene is very good for the antenna application, and with the magnetic the ferrite materials. These are some materials which for antenna applications, VO2 can be used for the switching for millimeter wave and terahertz application. And liquid crystal can use as the antenna substrate, supporting substrate, and which can be change the dielectric properties of the material using the biasing. So we can design the tunable antenna, tunable filter, phase shifter, and there's a variety of the because this is very cheap and need a very low power. So other is the BST ferroelectric type material need very high voltage, high power. But these material can be used for low application. The semiconductor vector diode. And this is the material type of material mechanism how we can change. So the like BST changing the permittivity with the applied electric field. So if we apply on the BST, apply the electric field on the BST, so you can change the permittivity. If you change the permittivity, you can change the delay. You can create the delay, or you can change the frequency of the antenna. But this one can be used only up to gigahertz, not to millimeter wave or the terahertz. The power consumption low to moderate still, and other is the ferromagnetic. Changing the permeability. Permeability is not so important for antenna because if you have the permeability change, the very loss. If you apply the magnetic field, you can change. But this ferromagnet is good for the designing RF devices, low frequency devices. And is the liquid crystal, the reorientation of the molecules charge changes the effective dielectric property. So effective dielectric property is very, very important for antenna design because this property can use either phase shift creating a phase shift or changing the frequency of the antenna. And simply we need the biasing voltage and can be used up to terahertz. So the liquid crystal is the good for the antenna applications. Another is the vector diode. Graphene also very good, but it need a lot of effort to use this thing. Another is the phase change material VO2. We can use the as a switch. So we for this VO2 we need to the heat. If you have the heating, you can change the insulator to metal. Another metal surface, we can use the different intelligent reconfiguring surface to create some type of the different properties for antenna applications. And they can use the terahertz. So the liquid crystal, graphene, and VO2 is very good for the millimeter wave terahertz. And the liquid crystal power consumption is very low compared to this ferroelectric and ferromagnetic section. So this liquid crystal material, tunable material. So this material have the two components. The one is the vertical and the parallel. So if you apply the voltage, the permittivity will change both components with biasing voltage. So you can control this biasing voltage very fine way. So if you control very fine way or fine control, so you can change the permittivity very small. So small change in the permittivity, you can change the antenna. You can create the phase shift using the changing the dielectric constant of the liquid system. So it is the square root of the epsilon r of the changing of the. So the good liquid crystal have, if you have the larger tunability, means parallel to the vertical, we have the large changing, so you have the more phase shift. So tunability is very important. So there are some material in the market which have the some tunability and good for up to 90 gigahertz, and which can be used at very high frequency. The tunable material is good for more than 10 gigahertz and up to terahertz we can use. So there are some materials available in the some research center or some company has this type of thing. So more focus of this tunable material development. The loss tangent for antenna applications should be low, and the tunability should be large to create the more delay. To create the more, if you have the more changing the tunability is more, you can change the frequency tunability is more, and you can create the shift, large shift in the phase shift. If you have the large phase shift between the two antenna, you can change the beam in wide direction. So the requirement of the antenna system, beamforming antenna system, you have to have the very wide coverage, which can use cover the wide area. So if you have the material researchers, so this is a very important demand for antenna research, antenna development. The loss tangent should be low, and the tunability should be very high, so which is good for the antenna application. So these are how we can use the liquid crystal material. So we have the different. This is the metal. So we have the like Mendel line and the digital line. So this is the liquid crystal material below this Mendel line for creating the phase shift. So this, if you apply the biasing voltage on this, you can change the phase. If you're changing the like permittivity 2.5 to 3.5, 1 gigahertz, you can create the phase. You can have the phase difference between the 290 or more than 90. You can create the more than 90, but you need very fine this Mendel line. So this is the concept. So if you create, if you add this phase shifter in the antenna, you can between two antenna, you can have the phase delay. You can change the beam. Another application, if you design the antenna using the liquid crystal, you can put your antenna on top of this and applied biasing voltage. You can change the permittivity. The changing the permittivity, you can change the uh, resonance frequency of the antenna. You can change the operating frequency of the antenna. So this is the one of the company Alkane I discussed later on.
Sir, sorry to interrupt you, sir.
Yes.
Actually, we are running shortage of time.
Okay.
And
Okay.
there are so many more keynote speakers. So please wind up
Okay. 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 No
within 5
problem.
to 7 minutes.
Okay. So
Thank you, sir.
this is the liquid crystal. How we can use the liquid crystal? This is the Mendel line, and below is the liquid crystal. Applying biasing voltage, and put the antenna array on top of this. So in this table you can see the comparison with the conventional antenna array compared to the liquid crystal based Alkane design. This is the startup company in the Germany. So they can reduce the power consumption around 4 times around, less than 4 times. So this is their claim. So if you reduce the power consumption, very important for satellite or airborne type antenna. So they can reduce the 3-4 time power consumption. This is very good for antenna application. So they have some first initial paper in 2012. Now they have the patent, and now they develop only the product like this product. So these are some applications of the beam results of this, and they have the one product. I think last year they launched in the market. They have the one phase array antenna which can cover the two frequencies receiving and transmitting, the K band and K band millimeter wave. So this antenna has around 4 times low power consumption and low cost. They have the other type of antenna. They put the DR antenna, and these are Mendel line, and there's the liquid crystal. Changing the permittivity of liquid crystal, you can change the beam in different directions. And there we have also developed the grid type of the array antenna. If you change the liquid crystal permittivity using the biasing voltage, you can change the beam in different directions. So that this technology also, because scan loss is very low, if you change the permittivity from 2.4 to 3.5, you can change the beam in different direction. So this is we have a patent on this technology. So we can change the beam from 8 to 26 degree without any phase shifter. This is the phase shifter less uh, phase array. So these are some beam. You can see the in different direction if you change the dielectric constant of the liquid crystals. And then I just discussed, if you have the patch antenna on this is the cavity, metal cavity, you have the liquid crystal inside the cavity and put the antenna over it. You can change the frequency of the antenna. You can tune the frequency. So this is a very good important. So in this paper, we have just studied which cavity is the best efficient for the liquid crystal to change the mode tuning range of the frequency. Another we have changed we have the liquid crystal cavity and put the array antenna, changing the liquid crystal permittivity, and can change the frequency from full millimeter wave. Then you can change the main beam in the different frequency at the different frequency by changing the liquid crystal permittivity. So these are just two directions. Then we have fabricated and filled the liquid crystal and measure. You can see the very good agreement between the simulation and measurement. And there's the other type of in the literature, they can use the both frequency and the pattern reconfigurable using the two layer of the liquid crystal, one layer for the frequency, another layer for the beam changing, reconfigurable for pattern reconfigurable. So they use the two layer of the liquid crystal, one for the frequency tunability of the frequency reconfigurable, and other is the pattern reconfigurable. And these are some Farad based. So Farad based requires a very high voltage around 60 to change the beam. So they use the four antenna and four phase shifter. Below is the Farad substrate and put the biasing voltage V1, V2, V3. So based on the controlling the biasing voltage, you can change the beam in different directions. We have the first is the 0, 0, another is the different voltage configuration to beam in this direction, other is the this direction. So you can, by changing this volting, biasing voltage, you can change the beam in different direction. This is also very good. Another is the graphene based. Graphene based also can be used for changing the beam in different direction by changing the biasing voltage of the with the very small part of the graphene here. Another is the liquid crystal. So biasing, they have the two liquid crystal here. If you have the different crystal like 0, 0 biasing, if you change the biasing, one is the higher voltage, one is lower voltage, you can have the beam in different direction. One important thing, the resonance frequency is the same. You just change the beam in different way. One is this one center, and one is this side. Another is the liquid crystal based liquid wave antenna, also very important for the 5G, 6G communication, IoT satellite communication. So liquid crystal based liquid wave antenna is very, very interesting. So no need very complex structure. You have one feed. Based on the liquid crystal biasing, you can change the beam in different directions without any circuit. So they have in the literature, they have some paper. You can see they have the liquid crystal here, and changing the biasing voltage, you can see the difference. And this is my summarize. I can summarize. So I have discussed the motivation of the tunable material, how we can use in the antenna technology, which can be used for beam steering antenna, or you can see another type I have discussed the grid array antenna. We can use the liquid crystal based grid array antenna to switch the beam in different directions. And this technology, I think, tunable material based technology in the future may be the very good technology because there is low cost and some component not available like phase shifter on terahertz or millimeter wave. And thank you everyone for listening. And I am very happy to have some questions.